I'm Benny, I'm the CEO of OPSWAT. What I'm going to talk about today is, first I was hoping to introduce also the company for the ones of you that maybe want to just get a high-level overview about the company. And then I'm going to talk about the value of multiscanning. So a bit about the company. The company was founded beginning of 2002. We are 50 employees. We are all in San Francisco. We have 50 OEMs, over 500 direct customers, and over 65 certified technology partners. Norman is one of them. A bit about what we ship today. We have three shipping products. One is the multiscanning product, Metascan MetaDefender. It's the same technology packaged differently to address different issues. We have our manageability framework, Oasis, and App Remover. And then we have Sandboxing, Secure Virtual Desktop, which is not the Norman Sandbox. It's maybe the same name, maybe confuse some marketing. It's much more a desktop isolation tool. So before I'm going to talk about the value of multiscanning, let's take 2 steps backward and let's ask ourselves, why multiscanning? And why do we really need to go and address multiscanning? So Randy did an awesome job kind of going and educating everybody about the threats, about social engineering. So we can even take it even backward and ask ourselves, why multiscanning? Or we are obviously trying to fight to address an issue. And whenever we're trying to address any issue, it doesn't have to be viruses. It could be anything else. It could be, for example, data or disaster of data recovery. So we're up against data recovery, and what we're having is maybe a backup solution. Let's say that we are against the military. So what we're up against, we're against the military. We need to know how many units they have, how many soldiers, how does the supply lines work, what type of ammunition do they use, how deep is their defense lines, and what we have. I mean, and then we should go and ask ourselves, what are the tools that we have to address or to go and to penetrate or to fight or to protect against this military. And then we should go and ask ourselves, what are the tools that we have? I mean, how many soldiers do we have? How well are we trained? How fast is our supply lines? Can we rate our units by any sort of system? So whenever we're going and actually trying to fight or to trying to address issues, we can actually go and ask ourselves 2 questions. What are the threats and that we're up against, and really what is the capability of our solutions? So in the multiscanning, it's obvious what we are up against. We're up against malware. What is the capability of our solutions? Yes, we have antiviruses. So let's try to go and look at the anti-malware industry and try to answer these 2 questions. What are the threats that we're up against, and what is the capability of our solutions? So I did that several weeks ago. What I did, I actually looked at Google images and simply put together a very simple Google query, malware count. Yeah, obviously there are much more sophisticated ways to go and do that. There is virus encyclopedias by Norman, by Symantec, by McAfee, and a bunch of others. So I was trying to actually get to some sort of a count, right? We are up against malware. So how many malwares are really out there? So there are many numbers out there. Though I did really do something that is very visual, and came up. I took 2 sources. One is McAfee, and another one is avtest.org. avtest.org is a company that certifies antivirus application, and clearly there is no consistency between the results, and McAfee claims that there are actually around 20 million more viruses that avtest does. Yes, the definition of malware by avtest and the definition of malware by McAfee could be different. However, we don't really know, and whenever we have 20 million malware or difference of 20 million malwares out there, can we really come up with a number? Now, you'll see completely different numbers. So, for example, Trend Micro will come up with completely different numbers. The different virus encyclopedia will come up with completely different numbers. It's even worse when we are looking at the difference of new malwares that are introduced to the market. So the difference in the detection rate of anti-malware application, you can see also that it varies, and every month, on a given month, McAfee can claim that there are 2 million new malwares, while every test 1.5 million, and vice versa on different months. So even there is no consistency about new malware that actually are being introduced to the industry. So it's clear that we cannot really measure, cannot really count how many malwares are really out there. So we said that there are actually two things that we actually need to get to address any issues. And again, what we're up against is obviously it's unknown, and what is the capability of our solutions? Let's go ahead and ask ourselves what is the capability. So let's try to measure the quality of antivirus applications. So do you have any ideas? I mean, let's say, how can you really check the quality of an antivirus application? So, for example, there are obviously various ways to go and check quality. And I can get it here to an open question, though it's obvious that, for example, the detection coverage. I mean, we can go and say, okay, the amount of viruses that a single antivirus engine will find or will detect could determine the quality of the antivirus engine. Another way to go and measure the response time is from an outbreak, how fast an antivirus engine will go and provide coverage or detection or protection against this threat. Another way to go and measure is operating system compatibility. So is this virus going to be found on Windows 2008 server and not be found on Windows 7? It's another, or 32-bit and 64-bit viruses is becoming an issue. Amounts of false positive, I mean, are there many false positives with this specific antivirus and so on? And obviously there are many other metrics. And to come up with these metrics, there are a bunch of companies that came up with measurements and with some ways to go and measure quality of antivirus engines. Think about the ranking system for antivirus engines, for antivirus applications. So there is a West Coast Labs, there is AV Comparatives, AV Tests, ICSA Labs, Virus Routing, Anti-Malware, NSS Labs, and actually there are a bunch of others. Actually, during the last hour, we found that actually there are a bunch of other companies also addressing and trying to measure the quality of antivirus applications. So I did another search, another very interesting search, and I was looking at two different, actually it's a very known company manufacturing this antivirus. I don't want to disclose the name. And I was looking at the test results of every test, and I was looking at results of just arbitrarily checked November 2010, February 2011, August 2011. And here we can actually go and see that there is no clear answer about the quality of the same antivirus application by two different certification vendors. Now, to address that, actually to address the inconsistency about the way that antivirus engines are being measured, there is an organization called NMTSO. It was founded by actually the previous CTO of Norman, and it's headquartered in San Francisco. The goal of NTSO is to define standards how to test an antivirus application. So although this organization was founded in 2008, clearly 2010 and up until now, there is no clear answer or no uniformity about how antivirus engines are being tested. So the conclusion is obvious. There is no current answer about the amount of threats, and there is no clear answer about the quality of antivirus applications. So, and whenever we have these two uncertainty, then obviously the more the better. The more the better. Let's try to take advantage of more engines, more opinions, and more tools, more weapons to go and fight against malware. So another question we can come up and ask ourselves is, can we go ahead and quantify? So by adding more antivirus engines, can we quantify how much protection we're actually adding to the global solution? So it's all if we're kind of looking at kind of this group. I mean, we are a small and cozy group here, though. Many numbers people that actually will appreciate numbers, and we want to actually quantify it. 5 is 10. Can we really quantify what is the advantage? So let's first kind of think about, okay, what are really the advantages of scanning with many antivirus engines, and also there are obviously disadvantages. So advantages that are obviously that are obvious is improving the malware detection, right? Improving, and by actually coming up with more engines, then we assuming that we'll actually detect more threats. Second, decrease time for an outbreak. So whenever there is a new virus coming up, how fast can we go ahead and our solution will go ahead and find a solution to detect this threat. And the third one that is also very obvious is increasing resiliency. So if an antivirus engine has an exploit, end of the day, an antivirus engine is a piece of code. So if there is a vulnerability in this specific engine, we should assume that the resiliency of our solution is going to be compromised. There are obviously disadvantages of using multiscanning, right? Any ideas? Somebody? All right, so false positives, right? Scan with more. You know, obviously, if you're going to scan more, we're going to get alerts. We could assume that we're going to get many more alerts, decreasing performance, right? So should we assume that, okay, obviously we need more CPU power to go ahead and third, it's going to cost more, right? So why? We need to license, get more expensive hardware, train new IP, and we'll go over that. So can we go ahead and actually quantify? So obviously there are many more advantages and more disadvantages, though typically, I mean, we've been in the multiscanning for several years already. Whenever we're talking to customers and actually talking and addressing and trying to go ahead and address these key points, this actually came up at the top 3 actually whenever we're looking at addressing and promoting multiscanning. So let's try to actually measure the detection coverage. So that we said it's one of. Let's try to really do that. So we should assume whenever if you see kind of this 100%, you see that that's going to be, let's say that that's the global amount of threats out there. And let's say, and we know that antivirus engines are not perfect. That's a given, right? And so let's say that antivirus A detection rate is X% and antivirus B is Y. So we should assume that some of the viruses are going to be unique. Though we should also assume that many of the viruses are going to be common to both antivirus engines, right? So whenever we're going trying to measure that, let's maybe try to assess what's really common here. What's this green stuff? So by looking at this green stuff and actually and talking to the antivirus companies and talking to researchers, then between antivirus companies, there are malware sharing programs. So whenever Norman finds a threat, they share it with Symantec. Whenever Symantec finds a threat, they share it with Norman, with Kaspersky, with a bunch of others. So there are already ready-made programs inside the antivirus company to share a threat. So second, there is the in the wild. Somebody's familiar with in the wild? Yeah. So I want to talk about it, Randy?
Pretty sure.
So in the wild, actually, there are companies that it's a group of researchers that share malware. You can actually see that the in the wild is not as active as the real malware sharing program between the antivirus companies. Though whenever there is a new virus that is out there, there is a group of researchers around the world that actually go and publish this and create a signature around that. Some of the certification companies, or the ones that actually check the quality, are actually measuring the quality of antivirus against in the wild. There are also malware sharing programs. So, for example, websites such as Multiscanning Online, Virus.com, and Joti are sharing malware samples between the antivirus companies. So, whenever, for example, a virus is being uploaded to Multiscanning Online, and we find out that Symantec detected threats and Norman does not, we send this information to Norman. Norman said, go analyze that using their sandbox, and then come up with a new signature, and vice versa. So clearly, there are common threats that are covered by the antivirus engine. So now let's kind of go and try to assess what will be the factors that goes and assess really the quality of a single antivirus engine. So what really makes an antivirus unique? So we mentioned that there are around 70 million, or Kathy said there are 70 million. Let's call it maybe 50 million viruses out there. So think about the challenge of putting together a software or software code to go and detect 50 million different viruses. Now, like any other software, we should assume that any software will have defects. So, and there are several models to go ahead and find and actually predict the amount of defects in any given code. There are, for example, ROM-AIR models. There are models that are linear to the amount of line of codes. There are models that are exponential to the amount of code. In any case, more lines of codes means more bugs. There are some industry standards about those, and it varies between 7 bugs to 1,000 lines of codes to 7 bugs to 1 million lines of codes. So that's really roughly the range. So the quality of the software code we found became a very interesting factor analyzing quality of antivirus engines, or quality of code of antivirus engines. Each one, or unfortunately, and maybe fortunately, each one of the antivirus engines has different software development methodologies, which means that different models should be implied on different companies, depends on the release cycles and so on, and the quality of the release. There are also other elements such as algorithm for engines, the signature database, the output frequency, the location of the analyst, and then also other factors. Location of the analyst is actually becoming very interesting. Think about holidays. Think about different countries, so different countries that observe different holidays and how that affects the staffing of the analyst and the ability to respond to different threats out there. So if we're trying to summarize the advantages, then we should assume that there are obviously going to be shared samples, and then there are going to be some uniqueness to each one of the antiviruses. One is what really makes the antivirus unique, and second is what are going to be the bugs. It's going to be the bugs, the regular bugs that are not going to be detected by antivirus 2, that antivirus 1 is actually going to go ahead and detect. So if somebody's interested, actually, I have another white paper actually talking about the probability, or you can actually put together some probability formulas and try to apply that on that, though again, it's going to be, you need to go and take the numbers based on the engines they're going to use and also understand the release cycle of each one of the antivirus companies. The second thing is that we can actually see here is the detection of time for an outbreak. So I took 2 viruses, 2 outbreaks here, uploaded to Multiscanning online, scanned by 20 antivirus engines. And clearly you can see on the left side, you can see how fast it took these 2 viruses to be detected by different antivirus engines. And you can see a vary here that actually expanded to over 76 hours on the left side and expanded over 20 hours on the right side. Though clearly, if you're looking at the time for an outbreak, the usage of multiscanning definitely decreased the time for an outbreak. We have to always remember that the multiscanning is going to be as best as the best antivirus outbreak, or the fastest one to detect. So that's actually clear and a simple example. Actually, I put that in a simulation and put together, actually in this simulation here on the left side, 30 antivirus engines goes down to 1, and then the average time for response to an outbreak, running the simulation of bunch of outbreak. Actually, the ratio here is 50 hours. So we have 50 hours here. I know it doesn't scale that much, however, I think it sends the message out, which means whenever you go down between 3 engines, so 3 engines, you should actually assume that the fastest time to detect an outbreak.
You said 3 or 30?
30. 30 is here and 50 is here. So I know it doesn't really scale, though this is really time, and this is really the amount of engines, so it really should. So actually I took the same one, I actually ran a live virus on that, and you can see that the amount of engines go down from 30, goes down to 1, and this specific antivirus engine, actually the first engine to go and detect these outbreaks, took its 50 hours. However, you can see really a difference between 25 engines to 30 engines. Same time to detect. So again, to go and count that, that's actually becomes that's pretty simple. I mean, it's the minimum time of a single antivirus engine to go ahead and detect them. The third one, the third advantage of multiscanning is vulnerabilities inside engines. So we took Soconia, everybody familiar with Soconia website, CERT, everybody familiar with CERT? So took these two websites and analyzed 4 antivirus engines, found in the past 3 years 2 to 1 vulnerabilities in a single engine. Time to fix those, typically vulnerabilities are being published only after a solution or fix is also being introduced together with them. It's very hard to assess how long of a time the engine was actually susceptible to this vulnerability. However, it's definitely an issue. And some of the issues could be as severe as buffer overflow. Some of the issues are more minor. However, the likelihood to, based on assessment of time for detection and so on, it's unlikely to find more than 3 antivirus engines that has the vulnerability in the same, or severe vulnerability in the same. So, yeah, again, if you're already interested actually to get the probabilities formulas, you can actually go and again refer back to my white paper. Let's go to disadvantage of multiscanning. So not everything is not everything is that let's look at what we are really going to, what we have to sacrifice here in order to get multiscanning. There are clear benefits here. So increased amount of false positives, increased performance, and costly. So if we're looking at false positives, so we should assume that if one engine has one false positive, so we mentioned that antivirus engines are actually sharing samples between each other. So we look at antivirus 1 and actually antivirus 2. So we should assume that some of these malwares should be shared. Why? Because there is Multiscan Online, there is virus local, there is Joti, there is the malware sharing sample. So we should assume that if one engine detects a malware, a false positive, another one should go ahead and detect a false positive. So is it really true? So I looked at actually a recent report of AV comparatives, actually that's August report, and I took 2 antivirus engines. You can see one antivirus engine on the left with 8 false positives detected, and another antivirus on the right with 10 false positives detected. And then I went to analyze the files. I wanted to see, okay, what really are we gaining here? And is 1 plus 1 is actually less than 2, and it is. I ended up with 14. Actually, that's from August report of the AV comparatives. You can actually go and by reading the report, I'm sure you'll be able to figure out which one are the antiviruses are. So clearly, the amount the antivirus engines are sharing samples, and the sharing samples is an advantage, and also it's a disadvantage whenever we're talking about false positives. However, if we're looking at the whole of how much actually we're going to lose here in terms of false positives, I would call it it's a mix. The interesting part is that by adding a whitelisting engine to a solution like that, it significantly decreases the amount of false positives out there. So by simply adding a whitelisting engine, I mean, many of them, I would say most of the antivirus engines does not have a whitelisting engine built in. Some of them does. Adding those significantly completely, and sometimes by adding a whitelisting engine, actually 1 plus 1 is actually less than 1, just based on the reports and based on the issues that we found. Performance. So the second thing is performance. So whenever we're going and analyzing performance, so clearly multiscanning cannot be fastest than the slowest engine, right? So we can't assume that that this metascan is going to do a major multiscanning is going to do magic and scan faster than the slowest. However, if we, let's say that we have 7 engines, so we have a solution with 7 engines, and we're looking at multiscanning, we should assume that, okay, we're talking about the linear, so if it took us, okay, if each one of the engines is 2 seconds, we should assume, okay, 14 seconds to go and scan the file, right? So just summarizing all of the scanning numbers. So is that really the truth? So investigating multiscanning, there are obvious redundant tasks between antivirus companies. For example, one interesting example is archives. Opening an archive is a very expensive task. And many of the files today are archives. Word documents today is an archive. Many of files transfers are archives. So looking at archives and reducing redundancies such as archives, such as detecting the file types, we found could theoretically decrease the overall CPU cycles that are being invested in each one of the multiscanning or whenever we're doing multiscanning. New CPU and memory architecture. So today, whenever you go to, whenever we go to Costco, whenever we go to any machine today is the 4 cores and above. Servers with multiple cores becoming very affordable now. So the CPUs and utilizing CPUs to different cores, to multiple cores, parallelizing the scanning to multiple cores are proven to decrease the overall performance. In addition, each one of the engines is different by their capability to detect different file types. So getting this knowledge, so for example, there are antivirus engines that will completely skip MP3 files, will not scan any links inside MP3 files. There are engines that will not know how to handle PDFs, will not know how to actually look at embedded objects inside PDFs. So by understanding these capabilities, there is no reason, and having this knowledge, there is no reason that scans will be done using specific engines. Usage of distributed computing, using of multiple processing are definitely things that are helping. One test is actually a little metascan here, and actually you can see here from left to right, so this projector is...
We need different colors.
Let's see here. This slide is tricky. Sorry about that. So, okay. So actually there's another line here. Actually, I'm going to look at the monitor to see where it ends. So, but what you see here in the graph, there is actually in the graph you see 1 engine, 3 engines, 8 engines that you can see here, which is actually our real results here. And I'm going to send you all of it here in the presentation, the PDF will be able to see that. So the presumed speed, so if you actually take this executable and multiply by 8 times, you end up somewhere here. If you take this segment here, and again, multiply by 8 times, you end up somewhere here. So clearly, you spend more time scanning and using multiscanning. However, the increase is not linear. The increase of performance is much more manageable than anticipated. So a few things about Metascan. By the way, after that you have demonstrations here, and I welcome you everybody to go and play with the product if you're interested. So the way, a little bit about the architecture, we have a file to scan. Actually, we have APIs here. It could be a file, could be a buffer, could be scanned. We have an optimizer to actually take understanding the file if it's an archive, opening it once, sometimes forcing the scanning in the RAM. After that, it's going to the scanning process. In the scanning process, we're trying to scan the content based on the engines that make sense to scan it with, and then you get scanning results, you get scan results via APIs or via database entry. You have post actions, you can actually go and put together the file in a specific location. and also you can read all of the data in a database. Packages of Metascan, we have no engines. Why no engines? We simply integrate to existing engines and pretty much adding a layer of APIs, adding a layer of reporting to that. 3 engines, 8 engines, 10 engines, 15 engines, 20 and 30 engines, also custom packages with engines of your choice. In terms of how to connect to Metascan, you can connect to Metascan locally, so on the local machine. Also you can connect remotely. So if there is a Linux machine or another machine remotely using web APIs, actually support REST, and some other custom protocol, you can connect to Metascan remotely. Another interesting deployment of Metascan is a distributed one. So for example, a Metascan can be a load balancer of other Metascans. So you can actually have one Metascan here without any engine, and then load balance requests to others. Metascan can also detect pre-installed antivirus applications and utilize those as another scanning engine. We also have a management station for that, so it's a built-in. So if there is a multiple deployments, for example, web deployments with over 300 Metascans in the same network, to go and check compliance for those, actually by using those to actually go and check compliance with the central location. We do have Metascan Online, available at metascanonline.com. Increasing amount of engines. Actually, right today we're already 18 engines. You can scan a file, and actually there is a live demo of Metascan on this website. And in terms of where we're going with Metascan, so today out of the box, if you go to portal.opswat.com, there is a Metascan with 8 antivirus engines, Metascan with 3, and Metascan with 0. Using OPSWAT Professional Services, as I mentioned, we expand to 30, 20, 50, and other packages. What we plan to do is actually having out-of-the-box solution with K7 SSO of independent net fraud, and actually move to a package with 12, package with 8, package with 4, package with 16, package with 20. They're going to be standalone installers that everybody will be able to use, releasing the Linux version. So we already have a whitelisting engine embedded to Metascan. The goal is to actually get the leader in the space of whitelisting and add that to an OEM for Metascan. Questions?
So just to clarify, when you were talking about the disadvantages of multi-scanning, and obviously the chart was hard to see, the assumption is 1 + 1 + 1 is 3 or 4, however many ones, it's linear. And your argument is the product, through use of optimization, by eliminating redundant tasks, by skipping files based on the capabilities of the engine, it's actually less than linear.
This is correct. So if 1 + 1 will be maybe 2, maybe 1.7, and somewhere like that. And another thing that actually I can, something that actually I can actually go ahead and do is actually disconnect this one here, since it's a very, very small audience. Well, so I think it's clear. Actually, it's easier to see it on this screen. So in terms of kind of where kind of anticipated is and where we are, just because the projections are. And also we have this graph available also the comments, or if somebody would need to. So to answer your question, yes, the argument is that it's not going to be the summarizing all of the times. It's going to be a number way less than that. And a part of the roadmap expands to improving the performance. A part of that is partnership with Intel. A part of that is continuing evolving and taking advantage of multi-core technologies out there.
Yeah, to speak to that, at Microsoft I did a ton of testing to see how we could optimize performance. And what I found was running 3 virus scanners simultaneously took marginally more time than the slowest of all the scanners. And the way my system worked was, even though we're using 11, what we did was we rotated scanners in. Keep 3 scanners running at all time, because the slowest scanner was pretty much what the time was going to be. one scanner finishes, rotate in another scanner. And by doing that, you can actually achieve a lot of optimization. It's surprising how much a computer can do. So our scanners don't take 100% of CPUs and use multiple, especially multiple processing.
Right.
So actually to address that, actually we met with the Microsoft team. So right now the Microsoft team is right now at 1,000 servers, and we are familiar with their solution. I can't expand and talk too much about that just because we have an NDA with Microsoft. I can tell you that there is a big difference between the approaches. So I can talk a lot about our approach. So now they expand to 1,000 servers.
Yeah, and we weren't using an API-driven approach too. The APIs were faster.
Any other questions? Thanks.